AP Calculus AB. Find the equation of a line tangent to f at the given point, and we're going to use the limit process here, and this is the limit process that we're going to use to find this derivative. So you need to use this limit process and show the limit the whole time until you actually take the limit, but you don't need to use this f prime at x notation. So I'm going to just start by saying that it's the limit as the change in x approaches 0. And here I'm going to fill in the blanks. So what I'm just going to take my function and fill it in here. My function is x squared plus 3. So we'll take x plus change in x squared plus 3. That's this part right here. Minus f of x, and f of x is x squared plus 3. All over change in x. And then from here, what we're going to do is we're just going to expand this thing, right? So we're going to expand this, and as we expand it, so I'm going to go ahead and expand. But I am going to write this limit process again, so I'm reminding my AP grader that I'm using this process. And if you take x plus change in x times x plus change in x, you'll get x squared plus 2x change in x plus change in x squared plus this 3 right here, plus this 3. Then I'm going to distribute this negative 1 to here and to here. So we get minus x squared minus 3 all over change in x. From here, we're going to simplify. And as we simplify, we're just going to gather like terms. And we're going to start again. Limit as the change in x approaches 0. The x squareds cancel, so we end up with 2x change in x plus change in x squared. Everything else gets canceled out over change in x. We're going to factor out change in x. And as we factor out change in x, we're going to get the limit as the change in x approaches 0. I know this, you're like, why do you keep writing this over and over? Because that's what your professors expect you to do, and that's what your AP reader would expect you to do also. So I'll factor out a change of x, and change of x times 2x would give us this 2x change in x back, plus change in x all over change in x. And this is really good news, because remember, our whole goal here is to take this limit, that is to let change in x go to 0, and we are finally able to do that because this change in x and this change in x cancel each other out. So we get that the limit as the change in x approaches 0 of 2x plus change in x, but I'm going to go ahead and let it equal 0, is equal to the first derivative, f prime at x, is equal to 2x. And that's just what we thought it was going to equal. Now what they've done is they've given us a point, so we need to take, right, they gave us the point up here, 1, 4. So we're going to take this x value and plug it in. We're going to take f prime at 1, which is equal to 2. And now we're going to use point slope theorem. So I'm going to use point slope. So here's point slope. And remember that point slope is y minus y sub 1 is equal to, in this case, f prime at 1 times x minus x sub 1, right? Because this is slope here, right? So we're going to get y minus 4 is equal to, and we found out the slope was 2 here, so 2 times x minus 1. And we simplify that out, and when we're done, we get y is equal to 2x plus 2. And there's our answer. And what we did there was we got the equation of the line tangent to our function at the point 1, 4. So I hope this is really helpful. This is kind of what you do early in calc, but you have to remember this because you can see it again. So hope this was helpful. Thanks for watching.